So let's start our today's topic. Let me now explain you the definition of shaft, that what shaft is. Shaft is also called as transmission shaft, okay, which is a rotating machine element, usually circular in cross section, which supports transmission elements like gears, pulleys, and sprockets, and it transmits the power. So as I explained you that the shaft is also called as transmission shaft because it carries the transmission elements, okay, like gear, pulleys, sprockets. So due to that, we can call shaft as a transmission elements, and it is used to transmit the power or the torque. The shaft is always stepped with maximum diameter in the middle of the portion and minimum diameter at the two ends, and where bearings are mounted. Okay, so this is the a typical representation of a shaft, that it has a maximum diameter at the middle of its cross section and minimum diameter at its ends. And at ends we generally put bearings, and you know that the function of the bearing is to support the shaft in its position. Okay, and the typical size of the shafts are given in this particular table, that 5, 6, 8, 10 and so on, like this. Suppose we are designing the shaft, and designing of shaft means that we are calculating the diameter of the shaft. And suppose after designing the shaft, we have calculated the diameter as 125 mm. So 125 mm is coming in between 120 and 140. So we will take the next value, that is 140. So it does not mean that we are rounding off this particular 125 as 140. In designing, as you know, that our objective is to take the higher value. So if our value is coming 125, so we will take the higher value as 140. So keep this in mind. These are some categories of transmission shaft. The shaft is also called as your axle. It is also called as spindle, counter shaft, jack shaft, or line shaft. Okay, the definitions are already given here. That what is axle? Okay, axle is used for shaft that supports rotating elements like wheels, hoisting drums or rope, sheaves, and which is fitted to the housing by means of bearing. Spindle is a short rotating shaft, and which you might have seen in your workshops in lathe machine. And just like that, we have counter shaft. It is a secondary shaft which is driven by the main shaft, and from which the power is supplied to a machine component. And jack shaft, it is an auxiliary or intermediate shaft, that in between the two shafts, if we are using another shaft, that shaft is called as your jack shaft. Then at last we have line shaft. It consists of a number of shafts which are connected in axial direction by means of coupling. Okay, so these are the different names of the shafts. Okay, now let me explain you how we will design the shaft. So first of all, you must keep this in mind, that shaft is designed on the basis of strength and rigidity. Okay, there are two ways to design the shaft. And now let me explain you one by one that the shaft designing on the basis of strength. Okay, so what will happen if the shaft is designed on the basis of its strength? It means, suppose there are different conditions. If a pure tensile stress is acting on the shaft, a pure bending moment is acting on the shaft, a pure torsional moment is acting on the shaft, or a combination of bending moment and torsional moments. So we will discuss one by one all these parameters. So if the shaft is subjected to pure tensile stress, we know sigma T will be equal to force divided by area, where area will be pi by 4 d square, and we know d is the diameter of the shaft. So from here, we will get the result as sigma T will be 4p divided by pi d square. And you know, in order to calculate the diameter of the shaft, we can say here d square will be equal to 4p divided by pi into sigma T. So from here, you can calculate the diameter of the shaft. Okay, this is the case when the shaft is subjected to pure tensile stress. Now, if the shaft is subjected to pure bending moment, it means now we will use bending equation, and from bending equation we know sigma b is equal to mby upon I. You are now very much familiar with this bending equation, pure tensile stress. Okay, and after solving this, we can get the bending stress as 32 mb upon pi d cube. Okay, so it means in order to find out d, from here you can say that we will use this formula 32 mb upon pi into sigma p. So from this formula, you can get d from here. Now, when the shaft is subjected to pure torsional moment, then we will use torsional equation. And from torsional equation, you know that tau is equal to mtr upon j. And by putting all these terms, we will get 16 mt upon pi d cube. From here also, you can get the value of diameter. But Now, what happens when the shaft is subjected to combination of loads? Okay, when the shaft is subjected to combination of loads, it means it is subjected to your normal stress and your shear stress. Then, in order to find out the principal stress and the principal shear stresses, we will construct a Mohr's circle, and after that, we will find out the normal stress, principal stress, and the principal shear stress. And after that, the principal stress sigma 1 will be this one, sigma x by 2 plus under root sigma x by 2 ka square plus tau ka square. This is coming with the help of principal stress theory. Okay, and principal shear stress from the Mohr circle, we are getting all these values. Okay, from the Mohr circle. So the maximum principal shear stress is given by tau max will be equal to this particular value. Now, when we will apply the maximum principal stress theory and maximum principal shear stress theory, what we will get the value of sigma 1. Okay, that is the maximum principal stress. Okay, so what we are doing in the previous formula, that is sigma x, we will take sigma x as 32 MB upon pi d cube. Okay, and tau we will take 16 MT upon pi d cube. After putting all these values in this equation, we are getting sigma 1 as this particular value. So this is the formula which we are getting now. So where sigma 1 is the maximum value of the maximum permissible stress, and maximum permissible stress will be a failure stress to the factor of safety. Okay, so this is your this relation is coming by maximum principal stress theory. Okay, and after that, by maximum principal shear stress theory, we are getting tau max as this value. Okay, यहाँ पे मैंने formula में values put करी, and we are getting tau max as this. Okay, and we know that maximum shear stress will be half of yield tensile strength, you can say, and permissible value of the maximum stress as failure stress, that is yield shear strength to the factor of safety, and this will be half of S by T divided by factor of safety. If we know the value of yield tensile strength, we will easily calculate the value of tau max. Okay. Now, next we have shaft design on the basis of rigidity basis. So before that, let me just tell you that maximum principal stress theory is applicable for the brittle materials. Okay, it is applicable. I can say it is applicable. It is applicable for the brittle materials, and maximum shear stress theory is applicable for maximum shear stress theory. You can say it is applicable for ductile materials. Because when we are going to design the shaft, definitely we must have a material for the shaft, and it will be a brittle material just like cast iron, and it might be a ductile material just like your steel, plain carbon steel. Okay, and depending upon that, we will use the formulas. Suppose we have a brittle materials, then we will use this formula, and suppose we have a ductile materials, then we will use this formula. That's tau max will be equal to 16 divided by pi d cube under root of mb square plus mt square. Okay. Now next we have shaft design on torsional rigidity basis. Okay. Now I explained you earlier that we have there are two types of ways in order to design the shaft design on the basis of strength, and second is on the basis of rigidity. So on the strength basis, I explained you that how we will design the shaft, and now let me explain you the designing of shaft on the basis of rigidity. Now in shaft, the shafts are designed on the basis of either torsional rigidity or lateral rigidity. Now we can say a shaft is said to be rigid on the basis of torsional rigidity. A shaft is said to be rigid if it does not twist too much. Okay, if it does not twist too much under the action of the external force that is acting on it. Similarly, we can say transmission shaft is said to be rigid on the basis of lateral rigidity if it does not deflect too much. If it does not deflect too much, then we can say our shaft is designing on the basis of lateral rigidity. Now, In certain applications like machine tools, spindles, it is necessary to design the, because in spindles, the spindles are rotating continuously with some RPM for number of hours continuously. And for that particular applications, you can say on the basis of permissible angle of twist per meter length of the shaft, the angle of twist will be given by, according to torsional equation, you can say theta will be equal to MT L upon JG. So this value is in radian. The value of theta is in radian here. Now, if we convert the radian into degree by multiplying by 180 by pi, we can get this formula. And now this will be in degree. Okay, this will be in degree. And it will be in radian. So for solid circular shaft, J is pi by 32 d4. If we have a hollow shaft, then diameter there, in hollow shaft there are two diameters, so outer minus inner की power 4 आ जाएगा हमारे पास. So now if we put the value of J in this equation, and we will get the value of theta, that is theta will be equal to 584 MTL upon GD4. So from here you can get the value of D, that is diameter of shaft, and in this way you can design the shaft on the basis of rigidity, torsion rigidity basis. Okay, so I hope both the methods are clear to you now. So now let me just explain you that how to solve the questions on the basis of shaft. See, this question says a transmission shaft. This is the transmission shaft which is given to us. It carries two pulleys B and C. So this is your pulley B and C. So definitely the pulley B is larger in size and pulley C is smaller in size. Diameter of pulley, this is the side view. Diameter of pulley B is 500 mm and diameter of pulley C is 250 mm. Okay. And power is supplied to the shaft by means of a vertical belt on the pulley B, which is then transmitted to pulley C carrying a horizontal belt. How the power is getting transmitted now? Power is getting transmitted by the shaft to the pulley B, which is carrying a vertical belt. You can say, आप देख भी सकते हो यहाँ पे P1 and P2 are acting in vertical directions. So the belt is in vertical direction. After that, the power is transmitting from belt from pulley B to pulley C, and pulley C is carrying a horizontal belt. This is how the power is getting transmitted. Now, after it says the maximum tension in the belt on the pulley B is 2.5 kilonewton. See, in belt we have two types of tensions. One is tight side, one is slack side. So on tight side we are taking a tension as higher, and on slack side we are taking a tension as lower. So it says that on higher side, or we can say the higher tension, maximum tension on the belt B is 2.5 kilonewton, or we can say 2500 Newton. The angle of wrap वो होता है कि जो आपका जो बेल्ट है वो कितना रैप हो रखा है उस पुली पे, ओके, कितना डिग्री पे रैप हो रखा है. So it says 180 degree, and the coefficient of friction is 0.24 between the belt and the pulley. Shaft is made of plain carbon steel. Now, plain carbon steel, it is a ductile material. So it is a ductile material, and the factor of safety is 3. Determine the shaft diameter on the basis of strength. So हमसे पूछा गया है determine the diameter of the shaft on strength basis, and yield tensile strength is given to us, that is 400 Newton per mm square. So how we will solve the question? So first of all, let me just explain this particular formula to you, that we have this tau max as 16 by pi d cube and the root of mb square plus mt square. Now from where you have when we were designing the shaft on the basis of strength, we have two formulas, that is this formula and this formula, and I explained you that this maximum principal stress theory is applicable for the brittle material, and this formula is applicable for the ductile materials. So out of these two formulas you have to apply this formula, okay, because we know our material is ductile. So that's why this formula is used over here. So final value, as you know, it will be clear to us that we will use this formula. Now tau max is here. What? Tau max is the maximum permissible shear stress, and maximum permissible shear stress, now how it will be calculated? It will be calculated by, see, this is tau max. that is failure stress, SSY divided by factor of safety, and SSY is equal to half of or 50% of SYT divided by factor of safety. So 0.5 into SYT is given to us, that is 400, divided by 3 factor of safety is also given to us. So from here you will calculate the value of tau max as 66.67. Okay, तो आप देख भी सकते हो 66.67 यहाँ पे आ गया. Now 16 by pi d cube. Now we have to find out bending moment and torsional moment. So let us try to find out these two terms. Now in step 2, they are finding the torsional moment, and torsional moment, as we know, it will be your mt will be equal to, that is force into radius. So if we are calculating the torsional moment for the bigger pulley, that is B pulley, so it will be P1 minus P2 into radius of the B pulley. So we have to find out P1 and P2 because we do not have the P1 and P2. P1 we have because he says that because P1 and P2 are the tensions. So we are saying that P1 is the tension on the tight side and P2 is the tension on the slack side. So P1 is given, that it is 2.5 kilonewton already, and P1 we can say it will be 2500 Newton. Okay. So ये देखो P1 is equal to 2.5 kilonewton and 2500 Newton. And there in belt we have the one formula, that is ratio of the tight side to the slack side is e raised to power of mu theta. So by using this formula, now you can get P1 by P2 is equal to e raised to power of mu theta, that is mu is 0.24. It is already given here, 0.24, and pi. So when you will get the value of this e raised to power 0.24 pi in your calculator, you will get 2.125. So P1 by P2, now we are getting a relation that is 2.125, and we know from here P2 will be equal to P1 divided by this value, and P1 already हमारे पास है, तो यहाँ से हमारे पास P2 आ गया. ठीक है ना, अगर P2 हमारे पास आ गया तो P1 हम इस फॉर्मूले से निकाल सकते हैं. So in this way you will get both the values P1 and P2. Okay, P1 is coming, P2 is coming this one. So into R that is radius of bigger pulley. तो diameter कितना था उसका? Diameter is given to us, that is 500. ये देखिए यहाँ पे, तो radius हो जाएगा हमारे पास 250. I hope it is clear. So now we are getting MT as 330,882.5 Newton mm. Okay, so this is the value which we are getting. Now we have left with only bending moment. Okay, so let us try to find out the bending moment also. So in step 3 we have bending moment. Now in order to find out the bending moment, look at the diagram. See, we have two type of pulleys. One pulley is acting in the vertical direction and second pulley is in the horizontal direction. So we will separately take both the cases. First we will take the vertical pulley and then we will take the horizontal pulley. So in vertical pulley, we know that there are two types of tensions which are acting in the vertical directions. So total vertical force that is acting on the shaft, we can say it will be P1 plus P2. और P1 और P2 हमारे पास हैं already, हम निकाल चुके हैं. उन दोनों को प्लस कीजिए and it will be becoming 3676.47 न्यूटन. I hope it is clear. अब एक चीज ध्यान रखिएगा, सिंस यहाँ पे मास नहीं दिया गया है पुली का, अगर पुली का मास भी गिवन होता देन इट विल आल्सो एक्ट इन द वर्टिकल डायरेक्शंस. सो आपको वो मास भी लेना पड़ेगा, और वो क्या होगा, मास गिवन है तो आपको वेट लेना पड़ेगा, W इज इक्वल टू वेट. सिंस यहाँ पे वेट है नहीं, सिंस यहाँ पे वेट 0 है, तो वी कैन से W इज इक्वल टू 0. बट अगर क्वेश्चन में गिवन आता है कि वेट भी है, तो यू विल हैव टू यूज W एज M इंटू G. मास कितना है वो गिवन होगा इंटू G 9.81. ओके, ये वैल्यू लेके आप वहां से वेट निकाल सकते हो. वेट भी इंक्लूड करना पड़ेगा इफ मास इज गिवन. So remember this thing, since here mass is not given, so we are neglecting it. Now what we are doing now, we have a vertical force which is 3676, and there are two reaction forces at the bearings RA and RD. Now by देखिए अब ये किस तरह से बन गया, it is just like this. We have P1 plus P2 and we have two reaction forces which is RA plus RD. Okay, RA RD. We have all the distances. This is 200. Okay, and this distance is 800, 600 plus. So what we will do? Simple, जो आपने मैं strength of material में पढ़ा हुआ है in shear force and bending moments में. Okay, the vertical force will be equal to downward force, and taking moment about A or D, आप reaction forces निकाल सकते हो. So reaction forces कैसे निकलना है, ये आपने already strength of material में पढ़ा हुआ है, आप इसको आसानी से निकाल सकते हो. Okay. So ये रिएक्शन फोर्सेज आ गए RA, दिस इज RD. ओके, अब बेंडिंग मोमेंट कैसे निकलेगा? सपोज यू आर finding out the bending moment at B. So bending moment will be force into perpendicular distance. That is 2941.18 into this distance. It is your 588232. वही आएगा आपका. And bending moment at C will be force, that is 735.29 into this distance. So आपके पास एक इस तरह का एक ये बन जाएगा बेंडिंग मोमेंट डायग्राम फॉर द वर्टिकल बेल्ट. ठीक है ना. अब आपको सिर्फ रिएक्शन फोर्सेस निकालनी है. रिएक्शन फोर्सेस कैसे निकालनी है ये आपको हम बता देते हैं कि देखिए वर्टिकल फोर्स क्या आ रहा है आपका, दैट इज P1 प्लस P2 और अपवार्ड फोर्स क्या लग रहा है RA प्लस RD. इसको आप इक्वेशन नंबर 1 बोल दीजिए. ये वैल्यू आपके पास है ऑलरेडी. अब टेकिंग मोमेंट अबाउट एनी पॉइंट, जैसे आप ए के अबाउट मोमेंट लोगे तो आप क्या आ जाएगा, एक इक्वेशन बनेगा दैट इज टेकिंग मोमेंट. सपोज इफ यू आर टेकिंग मोमेंट एट या अबाउट अगर ए ले रहे हो आप, अगर इसके अबाउट मोमेंट ले रहे हो आप इस पॉइंट के अबाउट, तो आप बोलोगे इट विल बी RD, क्योंकि RD तो है ये, दिस इज RD. सो इट विल बी, यू कैन से दिस इज RD इनटू दिस डिस्टेंस, होल डिस्टेंस. हाउ मच इज दिस? दिस इज 1000. दूसरा फोर्स कौन सा लग रहा है? दिस वन. तो आप बोलोगे दूसरा फोर्स लग रहा है 3676.47 इनटू हाउ मच? 200 विल बी इक्वल टू 0. अब यहां से आपके पास RD अननोन है. RD आ जाएगा यहाँ से. RD फ्रॉम वेयर इज कमिंग, जब आप इसको सॉल्व करोगे इस इक्वेशन को, 2941.18. व्हेन यू हैव RD, सो यू कैन से RD फ्रॉम हियर, सॉरी RA फ्रॉम वन RA will be equal to that is 3676.47 minus RD, that is 2941.18. आप इसको सॉल्व कीजिए, आपके पास RA आ जाएगा एंड इट विल बी 735 आ रहा है यहाँ पे 735.29 वही आएगा. आप करके देख सकते हो. ये चीजें हम यहाँ पे इन्होंने एक्सप्लेन क्यों नहीं करी हैं, बिकॉज दे आर एज्यूमिंग दैट यू नो ऑल दीज वैल्यूज की किस तरह से रिएक्शन फोर्सेज निकालनी है. ठीक है ना. मैंने आपको बता भी दिया, एक्सप्लेन कर दिया कैसे करना है आपने. सो ये आया किसके लिए? हॉरिजॉन्टल प्लेन के लिए, या हॉरिजॉन्टल जो सॉरी वर्टिकल बेल्ट के लिए. सेम फार्मूला आपको अप्लाई करना है पर वर्टिकल के लिए. अब वर्टिकल के लिए भी सपोज आपने क्या कर लिया, एक शाफ्ट कंसीडर कर लिया इस तरह से. यू हैव वन रिएक्शन फोर्स ओवर हेयर, another reaction force is here RD. Now vertical belt is at C. no ये पहले वाला तो बिगर पुली का बात करिए. बिगर पुली तो आपका कौन सा था? बिगर पुली आपका ये था B वाला, और वो वर्टिकल था. ठीक है. और दूसरा हॉरिजॉन्टल की बात करते हैं. ठीक है. दिस इज योर, इसको इस तरह से ले लेते हैं हॉरिजॉन्टल प्लेन के लिए. एंड यहाँ पे आ रहा है आपका P3 प्लस P4. डिस्टेंस इज 200 and this distance is 800. ठीक है ना. P3 और P4 चाहिए आपको पाप. It means you will now, if you have the value of P3 and P4, then you will definitely calculate the reaction forces now. So P3 by P4, you know it will be equal to e raised to power of mu theta. और वो आपके पास सेम आएगा जो यहाँ पे था, because coefficient of friction is same. So it will be 2.125. अब मैक्सिमम टेंशन जैसे आपको गिवन, अब आपको वो आप ऑलरेडी ले चुके हो कि मैक्सिमम टेंशन आपके पास 2.5 न्यूटन था. Now how we will find out the P3 and P4? तो यहाँ पे देख लीजिए आप, by this equation, torque is transmitting from pulley B to pulley C, so we can say that MT will be equal to P3 minus P4 into R. इस फॉर्मूले का यूज कर सकते हो आप. MT ऑलरेडी हमारे पास है, P3 minus P4 into 125 R2. R2 means radius of pulley C. तो 250 डायमीटर है पुली C का, और इसका रेडियस बन जाएगा 125. आफ्टर दैट यू विल गेट P3 minus P4 विल बी इक्वल टू 125 से डिवाइड कर दो उस वैल्यू को, ये वैल्यू आ जाएगा आपके पास. और ये तो हमने ऑलरेडी मैंने बता दिया पीछे आपको. व्हाट वी विल डू नाउ, अब इक्वेशन नंबर ए में देयर आर टू अननोन्स P3 एंड P4. इफ फ्रॉम इक्वेशन नंबर बी सपोज वी आर सेइंग दैट P3 विल बी इक्वल टू P4 into 2.125. मतलब P3 को अगर आप 2.125 P4 के बराबर मान लेते हो और यहाँ पे P3 की वैल्यू भर देते हो, तो इसमें सिर्फ P4 ही आएगा. तो देयर इज ओनली वन अननोन विच इज P4. तो फ्रॉम हियर यू कैन कैलकुलेट P4 एंड P4 वैल्यू इज दिस वन. और P4 के बाद आप इस वाले इक्वेशन से यू कैन कैलकुलेट योर P3 एज दिस वन. सो आफ्टर गेटिंग द टेंशंस, नाउ रिएक्शन फोर्सेस निकालिए. एंड रिएक्शन फोर्सेस क्या आएंगी आपके पास? ये आ गए ये आ गया आर डी, दिस इज आर ए, एंड दिस इज योर P3 प्लस P4. Okay, and bending moment, this one and this one. Now this is your bending moment diagram. अब यहाँ पे एक चीज देखिए, आपको हॉरिजॉन्टल बेल्ट के लिए अलग बेंडिंग मोमेंट डायग्राम बना, वर्टिकल के लिए अलग बना. सो अब आपको रिजल्टेंट बेंडिंग मोमेंट डायग्राम बनाना पड़ेगा. दिस इज योर रिजल्टेंट बेंडिंग मोमेंट डायग्राम. एंड हाउ वी विल कैलकुलेट द रिजल्टेंट बेंडिंग मोमेंट फॉर B will be this value square plus this value square under root, and we are getting this value. Similarly for C pulley, we are getting this value. Out of these two values, whichever value is the maximum value or the higher value, take that value. Okay, suppose we are getting the higher value as 1185625.45. It means bending moment at pulley C is more than pulley B. Okay, so आपने वही bending moment लेना है, वही लिया हमने, देखिए यहाँ पे. So now in this equation we have all the values. We have bending moment, that is the maximum bending moment, and we have the torsional moment, and then tau maximum, that is permissible shear stress, is also given to us. So now from here there is only one unknown, which is D. So easily you can calculate the diameter of the shaft, that is 45.47. Okay, 45.47, this will be your answer. So I hope this question is clear. This question is little lengthy question, as you can see, but it is not difficult. If you practice this question, it is not at all a difficult question. It is very easy question, but yes, it is a lengthy question. And if you will get any problem in this question, then you can definitely text me. I will try to explain you that how to solve this question. Don't hesitate to ask any questions. Okay, बस ये ध्यान रखिएगा कि suppose there are different cases now. Suppose we are taking a case that a shaft is carrying, suppose once again, two pulleys, and both the pulleys are acting in the vertical direction, means the tensions are acting in the vertical direction. So आपको फिर वहां पे क्या करना, एक ही डायग्राम बनाना पड़ेगा. There is no need to draw the separate diagrams. आपने एक ही डायग्राम बनाना है, उसी एक ही डायग्राम में जो बैक से बेंडिंग मोमेंट होगा वो ले लीजिए, और वो हमारे लिए आसान हो जाएगा. Okay, so I hope now this will be clear to you.